All right, guys, so we are going to work on finishing up some of these identities that are on your sheets. I kind of using some of them and entering the idea. The ones we're going to look at today, we're going to review some more sum and difference, including some kind of questions that are on your quiz. And then we're going to concentrate on these multiple and half angle ones. All right, so remember, this is where we looked last week. It was the sum of angles and the difference of angles in the middle of your reference sheet. And we used a unit circle to replace some values. So those are the two things we're going to use to do the top of 9B. Everybody with me at the top of 9B? I do need you to know these are verified questions, and there actually is a verified question like this on the quiz, okay? There's some of the easiest verified questions you're ever going to have to do, and I'll show you why. So this first one says, verify that the sine of pi minus x is equal to just the sine of x. So if you go to your reference sheet, can you find the sine of a minus b? I think it says sine of a minus b equals sine of a cosine of b minus cosine of a sine of b. Do you find it there? And for this question, a is going to be pi and b is going to be x. Verify, remember, means you can only work with one side. So I am going to work with this left-hand side over here and expand it according to what we just tried to scribble up there. So it would say the sine of a, but a is really what for our example here? Pi, times the cosine of b, but b is x, and then it said minus the cosine of a again is pi, times the sine of b, and b was x. So I just expanded that left-hand side using the identity off the sheet. Is everybody okay with that? Because you're going to have to be able to do this. All right. Then flip your sheet over. What is the ordered pair at pi? Is negative 1, 0. So which of those is the sine value? 0. Times the cosine of x minus the cosine at pi is negative 1 times the sine of x. So what's going to happen to that? 0 times cosine is just 0. Minus a negative 1 will become plus positive 1. So we're left with 1 times the sine of x. Does that seem like it's equal to what we were supposed to get? So that's the proof, okay? So we expanded it, we replaced the values, and we simplified it. Seem pretty easy? Okay, so can you try this one? This is going to be your A and B. We're using, let's see. It's right down here, this one, right? Because it's a plus b up here. So sine of a cosine of b would be what? Sine of 270 times cosine of theta plus, then it says cosine a sine b. So that would be cosine of 270 degrees times sine of b would be sine of theta. Okay, that was the expanding. Then if we go to 270, I think the ordered pair is 0, negative 1. Is that correct, guys? So the sine would be negative 1 times the cosine of theta plus the cosine would be 0 times the sine of theta. And this would become 0, and we'd end up with a negative cosine of theta, which is what we were supposed to get according to the right-hand side up here. Okay. I need you to understand though, because it's a verify question, you have to show those steps. Does everybody understand what I'm saying? That's the whole point of a verify. You can't just say, well, clearly it equals a negative cosine. You have to show the steps and the replacement and whatever. But, and we'll do a couple more of those, either on the homework or the review for the quiz, but does it seem pretty straightforward? All right, now, this one is done for you on your sheet, okay? This is a kind of complicated equation solving using these laws. And it says here, just for exposure, I did not put this on a summative. So if you guys could help me with, we're using these two right up here, help me expand this. So when it says plus, we're using the first one. Sine of A for this example would be pi over 2 cosine of B. Here's our A, here's our B. Be x plus cosine of A sine of B. Okay, then it keeps going. Let's see, I'll switch colors here to plus. This time it's cosine, so it's this one you're using now. This is A and B. So it would be cosine of A times cosine of B minus sine of A times sine of B. That's a lot of hooey. Okay, so help me quick. What is the sine at pi over 2? 1. What is the cosine at pi over 2? What is the cosine at pi over 2? Whoops. And the sine at pi over 2? Okay, what's left? One times cosine minus 1 times sine. Everybody okay? Now, this is a weird equation we talked really vaguely about when we did. You could leave it equals to 0, but it's basically saying the sine has to equal the cosine, right? Where is that true? 2 places on the unit circle where the sine and cosine are equal, guys. Pi over 4, and they're both negative in quadrant 3, right? At 5 pi over 4? Okay. All right, so did we get it right? Is that what it says on your sheet for that question? Because it was already done for you, I think. Okay, so let's go to the one we're gonna try. All right, so we're gonna use sine A plus B right here. And then the second thing we'll use is sine A minus B. But we're using a pi over 3, but we're just gonna expand it first. So first it will say, using this, A and B, or alpha and beta here, sine x times cosine what? What's our beta or B? Pi over 3. And now on this second part here, it says plus cosine x sine of pi over 3. Well, that's lovely. Then I'm going to switch, because now I'm supposed to use A minus B, which is this guy. So it said, the equation here said plus, and then it's sine A cosine B. So sine x cosine pi over 3 minus cosine A sine B, which would be cosine x sine pi over 3 equals 1. Oh, that's a hot mess. Okay, someone, what is the cosine at pi over 3? What's the ordered pair at pi over 3? 1/2 comma square root of 3 over 2. Do I have that right? Okay, so this would be sine of x times 1/2 plus cosine of x times square root of 3 over 2 plus sine of x times 1/2 minus cosine of x times, someone turning that off, square root of 3 over 2 equals 1. Okay, anything cancel out or anything fun? This is a positive cosine of x times the square root of 3 over 2, and this is a negative cosine of x times the square root of 3 over 2. Is everybody good? So that would make 0. Anybody know what else happens? What is the sine of x times a half plus the sine of x times a half? Yeah, just a sine of x. Because we could put the half out front, right? So it's half a sine plus half a sine is a whole sine. Everybody okay? Equals 1. Well, that seems like something we can find on our unit circle. Can you figure out where the sine is 1? I think it's only one place, isn't it? Pi over 2 maybe? Okay. Would you be okay with me saying that's not on the quiz? Because that seems like just a ton of writing and solving, right? All right. Now, we're going to talk the rest of the hour today about these multiple angle identities or half angle identities. These are super useful in calculus, and so you need to be really familiar with them, particularly this one. Miss Gupta always says I need to make you memorize this one, but I'm just like, if you only have to memorize that one, I think you could memorize it next year when you're in calculus, don't you? So sine 2 theta equals 2 times the sine times the cosine. All right, now there's something weird that happens over here. Cosine of 2 theta, there's 3 different options. Everybody see that? For cosine of 2 theta, you can use any one of those 3 and you'll get an identical answer. And I could spend time showing you why. Okay, cosine squared can be replaced with a 1 minus sine squared, which would give you 1 minus 2 sine squared. Sine squared could be replaced with a 1 minus cosine squared, which when you distributed the negative, you'd get a 2 cosine squared minus 1. I usually just use this top one because it always gives you a common denominator and you never have to worry about getting a common denominator. So, but it doesn't matter. Any of those will work. And then the tangent of 2 theta is kind of miserable mess here. I do want to tell you that if you happen to have already calculated the sine of 2 theta and the cosine of 2 theta, then just like any other version of tangent, it is equal to sine over cosine. Let me write that here. And I don't care if you write this on your reference sheet, you're not going to get to use this one anyway, but it's also equal to the sine of 2 theta over the cosine of 2 theta. Does that make sense, guys, that sine equals, or tangent equals sine over cosine? So the tangent of 2 theta is also the sine of 2 theta over the cosine of 2. Okay. Half angle identities, much more complicated, as you can see. Most complicated of all is this plus or minus out in front, and I will explain that when we get to one. But you have to figure out what quadrant it would land in, and then figure out the sign of the function in that quadrant. All right, and over here, if you had to, so this is also equal to the sine of theta over 2 divided by the cosine of theta over 2. You wouldn't want to do that unless you had already had to calculate these two, and then putting one over the other would be good. And that's where this comes from right here. But these are nice because they don't have that plus or minus. So you might want to choose one of those sometimes. Okay, first all we're going to do is play the I recognize it game. Can anybody find one that says cosine squared minus sine squared on there? What is cosine squared minus sine squared? Yes, this is a cosine of 2 theta, but what is our theta? 11 degrees. So you would say it is the cosine of 211 degrees or the cosine of 22 degrees. Is this coming back to you? We did this on Friday with some, I think. Was it Friday? Thursday, right? You had off Friday. Okay. Let's try this one. 2 sine cosine. What is a 2 sine cosine? Anybody find it? 2 times sine times cosine is a sine of 2 theta. So it's 2 times, what is our theta in this question? Pi over 5. So you could also write it as the sine of 2 pi over 5. All right, now this one's going to have an A, and you don't have to evaluate these at all. Just make a trade to simplify. 2 tan 3a over 1 minus tan squared of 3a. Ooh, 2 tan over 1 minus tan squared. Anybody find it? What is that one? Tan of 2 theta, only what is our theta? 3a. So how could I simplify that? Don't overthink it, guys. Just tangent of 6a. Okay. Number 21, 2 cosine squared minus 1. 2 cosine squared minus 1 is a cosine of 2 theta, and our theta in this example is 3 pi over 7. So how would that simplify? Anybody besides Star awake this morning? What's 2 times? Yes, it would just be cosine of 6 pi over 7. All right, 1 minus 2 sine squared. 1 minus 2 sine squared is a cosine of 2 theta, where theta is 55 degrees. So that would simplify to what, guys? Cosine of 110. Good job. And one more. Look carefully for this one. Sine over 1 plus cosine. Anybody find it? Tan theta over 2, so we'd have an 8x over 2, which would be the tangent of a 4x. Do those seem easy enough? All right. Now we're going to have to actually use some values off our unit circle. All right, so this one is done for you, so you can just watch. It says if the sign is 1/4 in the interval or on the interval from 0 to 90, what is that telling us? What quadrant am I in? 0 to 90 is in quadrant 1. You label it. Okay, so these are draw questions, guys. Label the sine 1/4 opposite over hypotenuse. Did I lose anybody yet? Opposite over hypotenuse. Then I have to do Pythagorean theorem. This would be 16 minus 1 would be 15. So this is square root of 15. And it's positive because of the quadrant I'm in. Is everybody okay? All right. And then it says find the exact value of sine 2 theta. So I go up here and I say I need the 2 times the sine of theta times the cosine of theta, which is 2 times the sine was 1/4 and the cosine is what? I think that blank is on your sheet. Doesn't it say cosine equals, what would the cosine be right here, guys? Adjacent over hypotenuse, square root of 15 over 4. I think it asked for that on your notes. So then it's 2 times 1/4 times the square root of 15 over 4. If we multiply straight across, we get 2 square roots of 15. And on the bottom, we have a 4 times 4 is 16. And what will that reduce to? Yep, square root of 15 over 8. Is that done for you, or do you need to write that down? Okay. So the only thing you might want to write down is at least the little draw. That was your hint, right? That you had to draw something. Anybody need more time on that slide, or are you good? Okay. We're going to go to this one. What is this telling us? Where are we going to draw this time? between pi and 3 pi over 2 is between 180 and 270, if you were in degrees. So that's a third quadrant. So we're going to draw our triangle in the third quadrant, which means when I put opposite over adjacent, what should I do for signs in that quadrant? Both are negative, left and down. Okay, if I do Pythagorean theorem, I get 9 and 16 equals hypotenuse squared. 9 plus 16 is 25. So the square root is 5. The hypotenuse is always positive. Everybody good? I think on your homework and on a quiz, I made these all come out nice special right triangles, I think. I'm not positive. In other words, there aren't radicals, but it's possible that I'm misleading you. I didn't do every homework problem again today. I'd have to look. All right, so we're supposed to do all three of these, okay? So the first one is the sine of 2 theta, which is this guy right here, 2 times a sine times a cosine. Maybe we should write those over here to help us do this faster. What is the sine of this mess? Opposite over hypotenuse would be negative 4/5. What would the cosine be? If they ask us to substitute a cosine, it would be negative 3/5. And up here, the tangent was 4/3 if we need that one. Okay, so sine of 2 theta is 2 times the sine, which is negative 4/5, times the cosine, which is negative 3/5. Okay, you can type that all in your calculator, or you can go straight across the top and across the bottom. 2 negatives should make it a positive. I think it's 24 over 25. Is anybody getting that? Everybody okay? All right, I'm going to switch to purple here and do the second one, cosine of 2 theta. Anybody care which one we use? There's 3 choices. I like this first one because it gives me a common denominator right off the bat. It says you take the cosine and square it. What was the cosine, guys? Negative 3/5. Square it minus the sine, which was negative 4/5. Square that and see what you get. You can use your calculator. Just make sure those negatives end up inside the parentheses or you ignore them completely. But this should be 9 over 25 minus 16 over 25 is, I got negative 7/25. Did anybody use their calculator and get that? Everybody okay? All right. Now, there's 2 ways to do this last one. I'm going to do it the long way, and then I'll show you the short way. So if you want to just hang on, and I'll show you the short way, but let me do it the long way just to prove that it works, okay? The long way would be to use this guy. Tangent of 2 theta equals 2 times the tangent, which right up here was 4/3, divided by 1 minus the tangent squared. Okay? The top would give me 8/3. The bottom would give me 1 minus 16/9, which would be 9/9 minus 16/9, or an 8/3 divided by a negative 7/9. And you flip the bottom over, right? So it'd be 8/3. Right now it's divided by negative 7/9, so it would be times 9 over negative 7. Which this is going to reduce, and you get negative 24/7. Can I show you the short way? Because it's way easier than that. Sorry, I went really fast because there's an easier way to do it. if you already know the double sine and the double cosine, how do you find the double tangent? What is tangent always defined as? Yeah, tangent of 2 theta is simply the sine of 2 theta divided by the cosine of 2 theta, okay? Well, we said the sine was 24/25, and I'm going to write it this way, divided by the cosine, which is negative 7/25. Can you flip the second one over and see what happens? Don't you end up with negative 24/7? Or 24 over negative 7? Was that way easier than the hot mess I did? Okay, but that only works if you've already calculated the double angle and for both, okay? If you haven't, it's probably faster to use their crazy formula and your calculator or whatever. All right, so this one, number 25, anybody tell me what quadrant I'm going to draw this in? Between pi over 2 and pi means I am in quadrant 2. And it says the tangent is negative square root of 3, which we could put over a 1. So that's opposite. We could actually find this angle, and we'll do that in a minute. But tangent is opposite over adjacent, square root of 3 and 1. Little bit tricky. Opposite over adjacent, square root of 3 over 1. Which one of those is negative, though? The 1, because it's going left. Everybody good? We're going up here, so we have to be careful there. Okay, if we do Pythagorean theorem, square root of 3 squared plus negative 1 squared equals hypotenuse squared. This squared would be 3, this squared would be 1. So 4 is hypotenuse squared, which makes the hypotenuse square root of 4 or 2. All right, we're supposed to find cosine of 2 theta. Shall we use the first one again? Cosine of 2 theta. Should we write them down quick? What is the cosine and sine of our newly drawn triangle there? The cosine would be adjacent over hypotenuse negative 1/2. And the sine would be positive square root of 3 over 2. Does that seem okay? So then when I go up here, I'm supposed to do cosine squared minus sine squared, which would be negative 1/2 squared minus square root of 3 over 2 squared. You can use your calculator, but this would become 1/4. What would happen if you square this, guys? Square root of 3 squared would be 3. On the bottom, square that and you get a 4. Simplifies to negative 2/4, because remember when you add and subtract fractions, you have to have a common denominator and keep the denominator, which reduces to negative 1/2. Okay. Can we talk real quickly through that? Can anybody find in quadrant 2 where the tangent is negative square root of 3? Just tell me in degrees. It's easier for our little brains. Where's the tangent negative square root of 3 in that quadrant? We're in this quadrant. Is it at 120? Is the tangent at 120 negative square root of 3? Okay. So it said find the cosine of 2 theta. So the cosine of 2 120s would be what? The cosine of 240 degrees? Can you go to 240 and tell me what the cosine is? Negative 1/2, okay? Did we end up with the right answer? That only worked because it was some special right triangle that was already on our unit circle. Yes. No, not at all, because most of them are not using your special right triangles. Yes, good question. Don't have to verify. I just wanted to show you that it worked for that one. Okay, this one is not on our unit circle anywhere. What quadrant am I going to draw it in? 3 pi over 2 and 2 pi is 270 and 360. That's a fourth quadrant, isn't it, guys? Everybody figure out where we're getting that? Okay, between 3 pi over 2 and 270 is here and here. Okay, I'm supposed to label the opposite over hypotenuse, 12/13. Okay, something's negative. The 12 would be. Anybody know their special right triangles? X squared plus negative 12 squared equals 13 squared. This is 144 and 169. When I subtract, I get 25. I know I'm going fast, but you could do this quickly on your calculator, right? So 5 or negative 5? 5 because it's going to the right. Everybody okay? All right. Now that we've drawn this, we're supposed to find the tangent of 2 theta. Oh, I'm sorry, it says theta over 2. I can read. I actually did this one wrong in my notes too because I didn't read. Okay, there are 3 choices. I don't think the one with the square root looks very fun. Does anybody else think that one doesn't look very fun? So which of these would you like to do? You want to do this one? Okay, we'll try this one. So it says we're going to need the sine and cosine. So before we start, can we just write those over here? The sine is negative 12/13. They told us that at the beginning up here, right? And the cosine we figured out was 5/13. All right. So if we're using this one, it says to take the sine. I'm going to write what we're doing. We're doing the theta over 2. And it's the sine, which is a negative 12/13, divided by a 1 plus the cosine. And anytime there's a fraction bar, you have to do the whole top and the whole bottom and then divide. So we end up with negative 12/13 over, this would be 13/13 plus 5/13 is 18/13. We flip it to, and what is 12/18 reduced to? By 4 to or by 6 to negative 2/3. Did anybody get a negative 2/3? Let's talk about how you could have done that on your calculator. What was it originally? Was it 12/13 on top? Negative 12/13, okay. Divided by, on the bottom it said 1, someone remind me. 1 plus 5/13. The calculator knows to divide before it adds, so math, enter, enter. Is that what we got? Okay. Yay. All right. I think we have 2 left to do. Is that right? Only 1? Oh, good. Last one. So it says, what quadrant am I in, guys? Between pi and 3 pi over 2 would be here, right? So I'm going to draw there. Tangent means I'm going to label opposite over adjacent. Anybody know what I have to remember? The 4 is negative, but then wouldn't tangent be? Yeah. Both negative. Left. Everybody good? Can I just tell you that this is going to be a 5 when you do Pythagorean theorem? Have we done enough with a 3 and a 4? And as long as the 3 and 4 are on the legs, the hypotenuse is 5. Okay. So I'm going to write, well, actually I'm not going to write anything down yet because it says to do cosine theta over 2. Okay, cosine theta over 2 is this, yes? There's only one option. So it says plus or minus a giant radical. All I need is the cosine of this. Can anybody tell me the cosine before we get started? The cosine of this here angle is, okay. So then when I go to substitute into here, I have a giant square root 1 plus a negative 3/5 all divided by 2. Now, if we want an exact answer, do you think it's going to work if we put the square root in our calculator? It's going to give us a decimal, right? So if you're going to put something in your calculator, just put what's in here in your calculator. I'm going to do it without a calculator. This would be 5/5 plus negative 3/5 would be 2/5 divided by 2, or 2/5 times 1/2, which would be 1/5. Did anybody do the insides only and get a 1/5? Okay. There's a plus or minus out front that's going to come back to haunt us, but let's finish simplifying this. What's the square root of 1? 1. What's the square root of 5? Nothing nice, right? What do we have to do when the square root is in the denominator? Could this get any uglier? Okay, we have plus or minus the square root of 5 over 5. Now you have to decide whether it's positive or negative, and this is kind of complicated. My brain thinks better in degrees. We agree on that? So we were in quadrant 3, which is somewhere between what? 180 and 270. We're supposed to find that angle divided by 2. So if I divide these by 2, because theta was somewhere between there and there, so theta divided by 2 would be somewhere between 90 and 135. Does everybody get that? What quadrant would I be in? If I was between 90 and 135, I would be somewhere in quadrant. It's not the whole quadrant, but it's somewhere in quadrant 2, right? Okay, so I took pi over 2 and 3 pi over 2, and I cut them in half. So I'd have pi over 2 and 3 pi over 4. It's somewhere, if you did it in radians, it's somewhere in quadrant 2. So in quadrant 2, we were finding a cosine. In quadrant 2, is a cosine positive or negative? Negative. So final answer is negative square root of 5 over 5. Whew. You gonna remember how we did that? We found the values for the first angle they asked, cut them in half, and figured out what the sine of it was. All right, so your homework is to finish 10B. I'm gonna stop the recording, but then find one where you think you might have to do what we just did, the square root plus or minus. See if you can find one on there for me, and I'll do it with you.